Hi, I'm going to analyze this logarithmic function graphically. Okay, let's start determine the domain range of this function. This natural log function is always defined on real number, positive real number. Okay, so x is strictly superior than 0. The domain range of this function, x strictly superior than 0, or x belongs to this interval 0 plus infinity. Okay, so now let's move on to calculate the limit at the point 0 and plus infinity. So let's start with a point 0. So the limit of f of x is approaching to 0 from the right hand side. So the limit of natural log of x is approaching to the 0 from right hand side. This one, let's do the substitution in order to calculate this limit, okay? Because we don't know the limit when you plug the 0 into the natural log of x, okay? So let's put t equal natural log of x. That's mean equivalent x equal exponential to the t. Okay. When x is going to 0, okay, t is going to minus infinity. Okay. Exponential minus infinity equals 0, right? So now the limit of natural log of x is approaching to the 0 from right hand side, equal the limit of exponential t is going to minus infinity. Okay, so this one you can write it down this way too. The limit of 1 over exponential t is going to plus infinity. Okay, the same thing, 1 over exponential plus infinity equals 0. Okay, let's move on to calculate the limit of natural log of x when x is approaching to plus infinity. Okay, so now you can plug your plus infinity into the natural log is plus infinity. Okay, we don't have to put the substitution because it's easy to calculate this limit. Okay, so now let's move on to the limit natural log of x over x is approaching to plus infinity. Okay, the reason why we're calculating this limit to determine the asymptote for this function. This function may has asymptote or doesn't have it. We don't know yet. Let's calculate this fraction first, then we decide this function it has asymptote or no. Okay, so this one, so the limit, if you plug the limit plus infinity into natural log x equal plus infinity over plus infinity is an indeterminate form, so we have to change another form in order to calculate this limit. So in this case, as you know, this function natural log x is derivative function over this interval from 0 to plus infinity, strictly superior than 0, and then also the function x is defined on real numbers, all real numbers. That means this function is continuous and derivative function. Okay, so that means we are allowed to apply Hopital rule here. Okay, what's the Hopital rule? Says the limit of natural log of x over x is approaching to plus infinity. Let's derivate this function. Equal the limit is 1 over x. The derivative function of x is 1. X is approaching to plus infinity. So let's plug in the plus infinity into x. So 1 over plus infinity equals 0. So now let's move on to calculate the derivative function for this function now. For all x strictly superior than 0, f continues and derivative function on this interval from 0 to plus infinity. That means our function is derivative function. Okay, so let's calculate derivative function. Okay, so we have x, f of x equal natural log of x. Now the derivative function of this function, f prime of x, is 1 over x. Okay, now this is the derivative function of this function, f prime of x equal 1 over x. Let's move on to the variation table, okay, where we can see the sign of f prime of x and the direction of the function as well. Okay, so this is the table. X is represent in input points. This is interval, okay, from 0 to plus infinity. The second line represents f prime of x. The third section for the f sign is a f. What's the direction this function is taking? Okay, so this function is strictly superior than 0. So x belongs to this interval. Equivalent f prime of x is strictly superior than 0. Okay, so that's mean our function is increasing. Okay, is increasing from 0 to plus infinity. We already calculate the limit at the point 0, which is minus infinity, and the plus infinity. Okay, now the function, what we know about this function, the function is increasing on this interval from 0 to plus infinity. But let's summarize this variation table. Since we know f prime of x is a positive function, as you see here the sign, okay, that means f of x is increasing function, from 0 to plus infinity. But it doesn't mean f of x is positive function because f prime of x is positive. Okay, we still don't know yet which interval this f of x as a function is positive or f of x is negative. Okay, so to determine that, let's calculate the input point number 1, okay, to see what's the image of output of 1. Okay, so let's calculate f of 1 equal natural log of 1. Just plug in number 1 into this function. It gives you 0. It's known natural log of 1 is 0. Okay, so that's mean output of this input 1 is 0. What does it mean? That mean this function is negative on this interval from 0 to 1 and is a positive from 1 to plus infinity. Okay, let's summarize that. X belongs to this interval from 0 to 1. Okay, that's mean f of x is negative function. Okay, negative, but it is included 0. Okay, and x belongs to 1 to plus infinity. Okay, that means f of x strictly superior than 0. As you know, always when you put f of x inferior or equal 0, the next one put f of x strictly superior than 0. We cannot put both of them with different direction. Okay, one of these inequalities is enough to put only one, not two functions equal to and equal to. Okay, so only one is enough. So now let's move on to the graph where we can put our function. Okay, as you see here, the function is coming from the lower right side of this quadrant. Okay, is coming from minus infinity and is going to cross the OX axis, horizontal axis at some point. How to determine this point where the function has an intersection with the OX axis? We have to solve the equation. So we have to solve the equation. So f of x, which is natural log of x, equals 0. That's mean x equal 1. Okay? That's mean the function f is going to cross horizontal axis at the point 1, 0 here. Okay? So our function is coming from this way. And also remember, we already calculated this fraction, the limit of f of x over x when x is approaching to plus infinity equals 0. What does it mean? F of x is accepted the horizontal axis as the asymptote, okay, of this function, which is this one. So the function is coming from the lower right side of this quadrant, coming this way, and then going to cross this horizontal axis at this point. So this is a function, it's coming this way, okay? So, and then it's going towards this one. Okay? That's mean this function is coming from minus infinity and coming up to cross this horizontal axis at the point 1, 0, okay? 1, 0, and keep going towards this line horizontal axis as an asymptote, okay? That's why we are calculated the limit of f of x over x. X is approaching to plus infinity, okay? So now this is the good place where I can stop. I will see you in next video.